I can use my special right triangles to find the exact values of sine, cosine, and tangent of 30, 45, and 60-degree angles. Let's start here with our 45-degree angle. Remember I told you to memorize the ratios for a 45, 45, 90 triangle? Here is what I meant. So I got x, I'll use x this time, x, and x times the square root of 2. So let's go through these. The sine of 45 degrees is the opposite, which is x, over x times the square root of 2. Notice my x's reduce, so I get 1 over the square root of 2. And remember, anything to do with radicals, you can't have square root of 2 or any square root in the denominator. So I'm going to get square root of 2 over 2. That's the exact answer of the sine of 45 degrees. Notice cosine of 45 degrees is going to be exactly the same. I'm not even going to write it, well, I'm not going to do new work, but 45 and 45, they're the same angle, so square root of 2 over 2, because I'm going to do x over x square roots of 2. Now, let's take a look at the tangent of 45 degrees. This is kind of a cool one, because it's opposite over adjacent, so I'm going to go x over x. X over x is 1. That's the exact answer. We'll do this in a second. Okay, I started talking about the next problem. I don't want to do that yet. So now let's look at 30, 60, 90. I'm going to redraw that so it looks more like a 30, 60, 90 triangle. So 30, 60, and 90. Short leg x, hypotenuse 2x, and the long leg is x times the square root of 3, which you need to have memorized. So let's go through this work here, and we're going to not have to do a whole bunch of things. Sine of 30 is going to be opposite x over the hypotenuse 2x, so it's 1/2. Cosine 30, adjacent x times the square root of 3 all over 2x. My x's reduce. Exact answer, square root of 3 over 2. Tangent of 30 degrees. Opposite over adjacent. X over x square roots of 3. Notice what happens. My x's reduce. I get 1 over the square root of 3. Can't have square root of 3 in the denominator. So we get square root of 3 over 3. Sine of 60 is the same as the cosine of 30. Square root of 3 over 2. Cosine of 30 is the same, excuse me, as the sine, hold it, I wrote 30, I meant 60. The cosine of 60 is the same as the sine of 30, so it's 1/2. I kind of ran a room here, so I'm going to write the tangent of 60 up here. Opposite of 60 is x times the square root of 3. Adjacent to 60 is x. So we get just the square root of 3. Now you can find the approximate numbers using your calculator. So let me throw up our calculator here. We want to use the scientific calculator on this. You don't want to use the graphing calculator in decimals. First off, notice we have different ways to measure angles. There's degrees and radians. That's why I want you to use the scientific decimals or your handheld calculator. On the scientific decimals, you got radians and degrees. We measure them in degrees. See how I'm switching those back and forth? Make sure it's in degrees. It defaults to degrees. You have to change it to radians. And then to find your trig functions, it's under functions. So you got to click the function. See, we have a bunch. We'll talk about some of these others in a few minutes. If I want to find the sine, I press sine, and then I'll go back to my main menu, and let's go for the sine of 30. The sine of 30 is 1/2. That's the exact answer. Let's do the cosine of 30, because that should be a kind of a weird one. So I go cosine 30, and that's a decimal. That's 0.866. But we said that the cosine of 30 was the square root of 3 over 2. So if I take the square root of 3 and I divide that by 2, notice we get the exact answer. You just have to know what it is. Now let's apply that to a problem. We look at this. It says, Matthias builds a ramp so his sister can access the back door of their house. The ramp is 12 feet to the house, slopes upwards from the ground at a 4-degree angle. What's the horizontal distance between the foot of the ramp and the house? And then we want to find the height of the ramp. So there's 2 problems here. First off, look at what you know and what you need to find out. I know I have a 4-degree angle. I know that. So I'm going to use my angle is going to be the degrees. I know the hypotenuse. The hypotenuse of my ramp is the part that she actually rolls up on. That's 12 feet. Let's find the horizontal distance first. Well, in relation to 4 degrees, that's going to be my adjacent side. So what function uses adjacent and hypotenuse? Well, that's cosine. So I'm going to say the cosine of 4 degrees equals, let me go back. I'm going to put in my variables first. The cosine of angle A is going to be the adjacent over the hypotenuse. Now I can plug in my numbers. I'm going to say the cosine of 4 equals x, because that's my adjacent side, over my hypotenuse. Now we do simple algebra. Multiply both sides by 12. So the exact answer is 12 times the cosine of 4. To find the horizontal distance, because we usually don't say, oh, that distance is 12 times the cosine of 4, we have a number. Remember, that's going to be a wavy equal sign I'm making. So it means I'm rounding it. So now I just type in my calculator. And I just do what it says. I go 12, function, cosine. The 4 goes in the parentheses. And we get about 12 feet then, don't we? 11.97, we're going to say that's going to be 12 feet. So that's the horizontal distance. Now let's turn around, let's find the vertical distance. Now, you got a couple different ways you could do it, but since we're doing our trig, let's go with our trig ratios. So I'm going to use angle A again. That's going to be opposite hypotenuse. Could I have used tangent? At this point you could have. I would have had a rounded answer there. But let's use sine. So we're going to say the sine of angle, need my marker. The sine of angle A is the opposite, which is y, over my hypotenuse is 12. I probably just, let's put in 4 right away. So the sine of 4. Now, in other words, I do the same thing that I did to solve for x. I multiply by 12. Y is 12 times the sine of 4. Now, 12 sine 4. Let's do that with our calculator. 12 sine 4. And yes, you can use your blue calculators. You can use your own calculators. And if you don't know how to do it, make sure I help you. So we get about 0.84 feet. And that kind of makes sense, doesn't it? We don't want that ramp to be very steep because it makes it kind of hard to go up. So it's only going up 0.84 feet, and we're actually going horizontally about 12 feet. Notice the hypotenuse is not the same because this was rounded, your 12 feet. It was a little bit less than 12. It wasn't exactly 12. Now, what happens if I want to find the angle? Well, if I want to find the angle, what I'm going to do is I'm going to use what are called the inverse function. Most of your calculators will have this on it. The inverse function on most of your calculators is going to be like a second. You have to hit second to get it. Now, on your Desmos calculator, if I just hit my functions, notice my second row are all my inverse functions. And then the others have nothing to do with trig. We'll use those later on when we do statistics. But they're just using trig. So if I know the sine, I know the cosine, I know the tangent, I'm going to hit my inverse function to find those.